Hello, hello. Welcome to the Plasma Implementers call number 26. Oh my God, we need explosions for our intros. Wow, this is Johan. Anyway, I have to give you a shout out every single episode because of the intro reactions. Okay, so let's dive right in. I guess we could start out with let's do a plasma group update to begin with.
That's Will. I want to hear it from the wildebeest.
Oh, all right. So update on my front is we have an implementation of like an example state channel on the OVM that was pushed last week and demonstrates how state channels are possible on the OVM and has some tests and whatnot to kind of show that.
Woo! And tons of fun stuff with optimistic rollup, and also there's a new repository for the OVM. But anyway, how about Leap DAO?
No updates. I don't think we're kind of busy preparing for Berlin Blockchain Week. We want to run there's another team that's called Social Distortion Protocol, and they're running a game that's called Planet A, and it's kind of a pop-up economy with a bit of everything, a bit of tragedy of the commons, a bit of prisoner's dilemma and stuff like that. And we're just supporting these guys to do things. That's it.
Cool. You had tons of updates last week, so don't worry that it's light. Andy, you want to go?
Sure. So I think basically we're still more or less on the implementation phase. We do have like a bunch of things that we are currently implementing, and I post a discussion on the Plasma build. So if we got time today, I would like to see if we can take a look on how we could make bounds work. Yeah.
Cool. Peter, the matter. Our crypto economics stuff. I've been saving you for last. But it seems Peter is not here, so maybe you go.
Okay, so we have done a bunch of stuff.
Yeah, I'm next.
Oh, you came back. Go ahead. It's your turn. Peter, do you have any update from you?
Yeah, okay, let me get update. So now I try to bind all our efforts from Plasma Group and Crypteconomics Labs and synchronize our work, start to dig inside the predicates and OVM GitHub repos that Carol mentioned. And my main goal is to write just basic MVP of a compression snark on Circom and wrap it inside predicate and make it available to bind it with different kind of plasmas. First with the plasma cache, because it's the most useful for UTXO-based plasmas. So, like nothing special updates. I will try to present some code for the next few weeks, and hope that I can make a good collaboration between our groups all together to do something good for DEF CON, for example. Yeah, that's it.
Cool. Crypto economics side.
So we have done a bunch of stuff this week. So these two we're working on to implement client side in Rust, and I was writing a universal decision contract for OVM, and we have done some research for
Property Factory.
Oh yeah, Property Factory with Korean Ben, and
Plasma query. I
Oh, yeah.
define the plasma query for client side.
Yes.
And
And
now,
Yeah, I was working on networking stuff between clients. Yeah, that's our updates.
yeah, that's about it. Thank you.
Yay, great. All right. Well, that was nice. Let's dive into any topics or discussions. I have a couple preloaded, as I always do. However, before we do that, is there anything on anyone's mind? I know, Andy, you mentioned one thing, so I will note that down. So we definitely talk about that. Is there anything that is particularly pressing for y'all?
We have one question.
Okay.
From Takamichi to Will.
Okay, for these 2 weeks, I was working on networking between clients. And if you have some idea of how clients interact with each other, networking, we hope we can communicate with other implementations using that kind of ABA or interfaces abstraction on the abstraction. So if you do have some thoughts about that stuff, I'd like to hear about it.
Sure. I think Carl and Ben can probably speak better to that because we've been working with some other people as well around networking. Obviously, the OVM itself does not, mandate any specific form of interaction between clients or dictate, how that works. So that's kind of open to the implementation. But Carl, do you want to chime in about the work that's been done?
Yeah, sure. So we actually contracted Whiteblock, shout out to Whiteblock, for doing a kind of test network, like point-to-point messaging network. And it basically is just a client-side interface, which hopefully doesn't change that much, which is definitely not finalized. Nothing here in this repo is finalized. And it has a backend which just is routing messages at this point. It would be nice if we had some like common way to just say, oh, I want to send a message to this person, and it just gets there. But that's that's basically where we were. We haven't really thought about it all that much, to be totally honest.
Yeah, that said, if that's something that you're diving into, I would love to schedule some time and talk through it and try to come up with something awesome.
Yeah. That's huge.
Let's do it sometime.
Yeah, don't take that repo as gospel, please. It's just seeing what it's an attempt. Anyway, any other things?
Well, I see Crypto Economy Lab has an issue on the OVM, and I'm pretty curious on that one. So we just discuss that as well. I think it's the how to quantify nested property on smart contract.
And you can always come to Fukuoka and talk about it with us.
Sure.
Okay.
I really like that problem though, so I'll talk about it a little bit. Basically, so Shuhei had just posted a comment last night, so I'll respond in person by saying, yes, I think bound variables is cool, is a good name. Basically, when we construct these predicates in the OVM, some of them sort of do this like nested variable thing. So for example, if you were to claim exists A such that exists B, such that property of A comma B, then you have to have some notion of the ability to sort of pass these properties inwards and have them as like variables. So we've been working through the details of that. Right now, on the client side of the OVM, we do something a little hacky, which we just call a property factory. where you give it an input and it spits out some arbitrary new property. And so it's sort of like a constructor function. But ideally what we want to be doing is passing, like have places where we can mark, like variables like an X and have that X substituted in. But within the limited context of the EVM and Solidity and things like this, that is a non-trivial problem. So we've been banging it out in the OVM issue number 1, which has been very exciting.
You know what? Let me actually quickly share my screen and just mention what we're talking about with this OVM repo. We just created this repo because we realized that there's like a lot of kind of stuff up in the air about the OVM and about how to like implement it and different layer 2 applications or constructions that we want to build on top of it. And so just like threw up a repo that says, okay, here's specs and contracts for any of these OVM constructions. So like, for instance, we have the main 3 OVM constructions, which are right here, layer 2 constructions, optimistic rollup, plasma, and state channels. And so we're just like, this is a public place for y'all to like post your specs. If you have like, even if it's like a different spec than what we have and you already came up with it, or I think it would be interesting to like submit a pull request and just like we can all chat about it and review. And I think that this can be like somewhat of a public place to kind of discuss. It also contains the universal adjudication contract, which can handle layer 2 adjudications, and the client OVM engine, we're something that's running the OVM in the client side, like the wallet. So yeah, this is a place y'all feel free to hop on and use it. Maybe this is a little bit of a segue to, because we're already talking about some OVM stuff. I'm interested in hearing about the state channel implementation from Will, who can kind of maybe walk us through some of the code to give a little bit better intuitions for what all this is kind of about.
Sure. Yeah, I'm happy to do that. And I think the one issue that's in the OVM repo, we can kind of touch on a concrete implementation of that and why it's an issue and why it needs to be solved as well. So let's see. I'll share my screen here. Let's see. Can you all see that? Cool. So this is the state channel client class that I've created. So, background, I think everybody is probably familiar with state channels, but the general concept is, multiple participants will lock up some sort of state or value on the main chain, and then they'll exchange messages on themselves in a way that abides by the rules set forth in the contract on the main chain. And then at some point, one or both of the participants will want to exit that channel, and they'll be able to do so if they submit the most recent message that was exchanged, representing the most recent state of that state channel. And if they try to exit a previous state that has like a previous balance maybe to their advantage, then that should be disprovable, right? So let's see. I guess we can start how you would start. So this assumes that you've already locked up your deposit on the main chain, both parties have, and then you can call this create new message function here that, if first it tries to get the channel for the counterparty that you want to create the message for. And one concept of state channels is address balance. So that's the only data that is required to be sent in a message. So my balance is this, your balance is that. Let's both agree on that. And so here we're creating a new message saying that this is the updated address balance and this is the recipient in question. So first, in our message DB that stores all the different messages that get passed, we look up to see, do we have a channel ID for this recipient? If we don't, or if we do, then we'll go ahead and get the most recent state channel, get the message, get the most recent message that's signed by me and figure out whether or not the channel's already exited, because then we obviously can't create a new message for it. And so let's see, if not last signed or not last. So yeah, like if we don't have a last signed message, or we don't have a last valid message, that's obviously an error condition. If it's exited, that's also an error condition. Otherwise, we get the last valid message that we've sent, and we add 1 to the nonce. And so the idea is that the messages have a monotonically increasing nonce, so that we can immediately tell what is the most recent message. And so that's how we set channel ID and nonce. Channel ID is already set. Nonce now gets set to be the last valid message is nonce plus 1. If the channel ID doesn't exist, now this represents the first message in the channel. So we just create a random channel ID, and we set the nonce to 1 because this is the first message. And then ultimately, you know, we want to send, saying that I'm the sender, send it to the recipient. And our message, all it needs to contain is the channel ID that we're talking about, the nonce, which would be 1 for initial messages and increase thereafter. And then the data is just the address balance. So, you know, I have this balance, you have that balance. And then we sign it and we save it locally just to make sure that we know about the message that we sent, and we send it to the other person. Now, I'm going to skip past this exit channel really quickly and go to handle message. So say that we just created a channel, we just sent a message to counterparty, their handle message will get called, and they'll get the signed message that I have sent them, and they'll parse the message, you know, from the signature and make sure it's valid and everything. And then they'll look for an existing message for that channel ID and nonce. So the idea there is, you know, if I sent a message to you and I've already signed it and saved it, then you sign it and you send it back to me. I should already have this message for this channel ID and this nonce, and I want to store your countersigned message because I want to know that, okay, this is signed by both of us. This represents the most recent valid state. So if it's existed, then we merge it together with what we have, basically just adding the counterparty signature and store that. Whether it exists or not, we want to store it. So now if not existing message, turn it on. Cool. So let's see. Message by channel. So, oh yeah, so if it is an existing message, that means that I've already sent that to you. So now I've just stored that you countersigned it, and I can return. There's no action required on my side. That's the most recent state. That's great. Now, if it didn't previously exist, that means that you've signed a message and sent it to me. Now I need to countersign it and send it to you if it's valid. So presumably there's some sort of logic in there that checks to make sure that the balances are right based on my knowledge of, you know, the world. And so there are 2 different options. We can either handle a new channel or handle a new message. So like if the nonce is 1, then that means you are trying to create a new channel. So I go in and I call handle channel, which just validates it and then signs and saves it, right? And then handle new message, I think is, yeah, we just want to make sure that the channel that we're talking about already exists, that it, you know, the message that you sent doesn't conflict with another message that we have, so like has the same nonce in a different balance or something like that. And we want to make sure that it's greater than the, you know, the nonce is greater than the most recent valid message. So no matter what, supposing everything checks out, we call sign and save message. So we sign the message, we send it back to the counterparty. Now, the last part of that is, well, that shows how we, you know, propose new messages, sign them, send them to the counterparty, they accept them, they countersign them, send them back, everybody saves them. We all know what the most recent valid message is. The thing that's really important is just being able to exit the channel. So we have money locked up on the main chain and we want that money back at some point. So in order to do that, we call exit channel and we pass in, you know, what the counterparty is. it gets the channel ID, makes sure it exists, gets the most recent message. So we have the most recent valid message, that is, meaning that both parties have signed it. And we're going to mark it as exited because it's going to be exited. Now here comes the actual decider logic, the exit claim that we're making. So in the OVM, everything on the main chain comes down to disputes. So we need to claim something, provide proof where we can, and then we're going to have a period of time during which this claim can be disputed. If it's not disputed in a valid manner, then the exit is valid, and whatever the exit is trying to exit, like that balance will be dispersed to the people in question, right? So this is kind of cryptic, but I think we've talked about it before in the OVM, where our claims are made up of deciders and inputs. So here, before we get into like this kind of cryptic exit claim, we'll just say that in order to exit, for an exit to be valid for state channels, you need to say that the other party has signed the most recent message. So like they know about it. And you need to say that you have not signed any message with a nonce greater than the current valid message. Meaning that the one that we're talking about, the other person has acknowledged it, and it's the most recent because I haven't signed anything with a nonce higher than it. So here, this and decider takes as input, you know, the left claim that's being made and the right claim that's being made, and says that both of these combined represent the claim I'm making. And we're saying, so this uses the signed by decider. We're saying that this most recent message has been signed by the counterparty. And then on the other one, this is a little bit more intense, a little more in the weeds, but the for all such that decider will decide true if every claim that's passed to it is true. And the claims that we're passing use this property factor. So basically what we're going to do is use this signed by quantifier that gets all the messages that are signed by the address that's passed in, which is me. So I'm saying for all the messages that are signed by me, the nonce for that message is less than the most recent message's nonce plus 1. So here's where that property factory comes into play, because you know we're going to get a bunch of messages back from the signed by quantifier, and we need to be able to then form multiple claims, one claim for each message, saying this message has a nonce less than that, and this message has a nonce less than that, and this message has a nonce less than that. And so in order to do that, we say like the output of this quantifier will be a bunch of signed messages. For each one of those signed messages, pass them to this property factory that will create a claim that says this message's nonce is less than our current message plus 1. And then the next message's nonce is less than the current message plus 1. So this claim needs to be represented in, you know, a neutral format. You can think like JSON or something like that in order to be passed to the layer 1 contract and layer 1 contract to make sense out of it. Obviously, this is not JSON. This is a specific function that needs to be created. So that's what Crypto Economics Lab is working on and really thinking through how this property factory can be removed and can be represented in a more general format. So I'll pause there because I know that I said a lot and it looks like there's a couple things in the chat. So let's see. Yeah. Let's see.
Yeah, this should be on Meister. Yeah.
I think that there are some small changes that are out on Meister, but nothing that is
yeah, should be about the same.
breakingly different. So yeah, we added in the concept of, for the quantifier, added in you know, a check to make sure that the channel ID is the correct channel ID and things like that. But the gist of it should be the same. So I guess, yeah, I'll pause. Does anybody have any questions about that? Any comments and anything where this doesn't make sense or doesn't work for state channels, anything like that?
I have a comment, which is I absolutely love lines 131 onwards. It is just my favorite thing. It is really, really cool to be able to express a state channel in a generic framework that you can express things like plasma and rollup on. I'm very excited.
Woo!
Well, all right. I'll give back control.
Maybe one question would be like, you have the AND decider here, and it has 2 inputs. Mm-hmm. Where can I find other types of deciders, and how many inputs can those have? Maybe that's a very trivial question, but.
Sure. So this one, the AND decider only has like a left and a right input because, you know, in theory, you could nest together multiple AND deciders, but that's a good point that, I mean, like the AND decider should be able to take in however many claims and decide them. So yeah, that can be improved. The deciders are just, so the examples directory of our OVM within our application is where the state channel client is. Right next to it is where all the deciders are. So here's the AND decider, and then for all such that, you know, decides true if everything that's passed to it decides true, and otherwise it decides false. There's a bunch of different ones as well. I won't go through all of them yet.
Cool, I'll have a look. Thank you.
Yeah. Any other questions or comments?
I have a question about after exit. I guess after exit, to exit, client should serialize this claim to ABI and send to claim property. And after decided period, state channel contract should recognize this claim and amount and withdrawal. So how do we how can contract recognize this claim?
Sure. So that's a good question, and also specifically omitted from this example. So this example doesn't really touch on the communication between layer 1 and layer 2. It assumes that, yeah, you've already locked up your funds on layer 1. This just is how you would exchange messages in a format that's ultimately exitable for the layer 1 contract. But yes, so this is what would be sent to layer 1, obviously in a serialized format that layer 1 can understand. And layer 1 will have contracts for all of these deciders. So the AND decider will have you know, a contract for it for all such that decider. Each one of these deciders will be a small, like simple contract that, you know, the AND one will just say, if this and that, then yes, otherwise no. And so we will send this information, this exact claim that we're making, to layer 1 to the adjudication contract to then decide on all of this stuff. And then you're right, the same thing, that would, it would decide immediately false if it could, and if it can't, then it opens up the claim to a dispute period. And then after that dispute period, it will disperse the funds according to, you know, this most recent signed message has an address balance associated with it. So for instance, let's see. So for instance, yeah, state channel message is just an address balance, which is just an address and a big number mapping. So that's contained within our message that we're saying that we want to exit. So layer 1 would be able to, supposing this is valid, supposing the dispute period lapses and there's no valid disputes, it would have the information about the balances that it needs to disperse to the different parties involved.
Okay, thank you very much.
Sure. Any other questions, comments, concerns?
I have a comment. So definitely this exists within the context of, you know, counterfactual and, you know, all of these different state channel implementations, you know, seller, whatever. And I think that it's important to note that, like, ideally what we can do is we can, cleanly integrate that tooling, the people who have built the generalized state channels, as long as the only piece that the OVM really is like touching is the adjudication section of their infrastructure. So the adjudication section is actually relatively small because it's pretty simple, right? It's like for all signed messages, there's no higher nods than whatever. And so this hopefully can kind of squeeze in and allow a client to gather information about its like current safety in whatever state channel it's in, and use the same kind of smart contracts and infrastructure that we're going to need for other things like Plasma and rollup. And it just will reduce the audit surface basically, and that is I think a big deal when we're thinking about smart contracts that are supposed to be holding enormous sums of value. So this is not supposed to be, this is the state channel implementation you all use, right? This is the state channel implementation that you all add your dope state channel implementations. Integrate your dope state channel implementations in.
Exactly. Yeah, the purpose of this is just to demonstrate that this is possible, right? We make no claims about this being the best implementation or even a good implementation. Just saying that this is possible, and walking through this, you should be able to see that this is possible and implement your state channel on the OVM. Cool. Well, with that, I think I'll stop sharing.
Great. Other topics, questions, concerns, things. I have one more, only one more, but I don't want to jump the gun because I'm,
Yeah.
Carl, I'll have to run. Was fun being here.
It was
Bye,
lovely.
guys. Sorry.
Thank you.
There's a meeting. Bye.
See ya.
Bye.
All right.
So I'm curious on the OVM contract side, because I think it's gonna be a conversation with pretty much quite a lot of predicates. How much more gas it would be causing? Because I think it will be cross-calling different contracts, right? If I understand it correctly. Is that a concern, or is it just pretty cheap, so nobody really cares?
Ben, you wanna?
Yeah. So let me play the question back and see if I'm hearing it right. Are you asking about the gas costs of the disputes in these contracts?
Yeah, sorry, because I think this makes every logic become a pretty small predicate. You compose a lot of small predicates. I think this is very nice. Just on the same time, if you use a lot of predicates in a row and you're doing verifying things, then it seems like you're every predicate is a cross contract calling, so it will have extra cost on it. So I mean, how do people feel on this? And I don't know.
Yeah, it's a great question, and I will say that I think it is definitely something that is a little up in the air in terms of we've got to figure out exactly how these contracts work before we can sort of make good determinations about that. Generally speaking, one of the things that we have seen is that effectively what's going on when you write the way to imagine writing some special purpose L2 dispute contract it's probably correct to think of that sort of as an optimization on the the underlying predicates. So for example, you could you can write a very custom dispute contract and still run and you could say, well, I have, you could give some intuitions that say, well, this dispute game I claim is sort of analogous or asomorphic to some OVM claim structure. So it is actually possible to run the OVM on the client side without it perfectly matching the generalized smart contract and running an optimized one, if you think that you have a proof that the optimized one is logically equivalent to the generic one. So that is one attack if this seems to be an issue. I mean, definitely, hopefully one of the goals of like optimistic execution in general is that like we should only have to do this in the case of disputes, right? So hopefully, like just because of the simple fact that disputes aren't going to happen very often, then like hopefully we don't have to worry about gas costs all that much. But if that does end up becoming an issue, like we can build, like you can imagine a like more intelligent compiler where you could actually take these logics and break them down. And so, for example, like you know, a very simple example of this would be like, you know, imagine you had like two ands sort of like nested in each other. So like A and B and C, right? So like we can construct a very clear logical proof that, you know, not C implies not A and B and C and D, because the C is false. Now, normally, like the way we would have to do that in the generic universal adjudicator is you would say, well, here's an implication of A and B and C. The implication is B and C, right? We like pull out the top level of the and. And then we go, okay, well, B and C implies C, and we pull out the next level. And so we have to trace through these two ands. But it's totally reasonable when you know that that logical formula can always be made to allow it to be disproven immediately with C. And so you can imagine that this would like reduce the gas and still sort of be valid because you have like a justified logical proof. The main reason that we think that avoiding that at first is appealing is, one, because disputes aren't going to happen very often is sort of the goal of the OVM in general. And two, because this allows us to rapidly iterate. So we can continuously try out new things without having to construct these custom proofs or custom reasoning. Because if we keep it all in sort of the longhand, then the OVM should be able to be the thing that tells us that we're achieving safety. So yeah, good question. Hopefully that was a useful and not too long answer.
Yeah, thanks. That's pretty useful.
All right. Well, any other things that folks are interested in? Okay. I don't know if I should say this, but you know, I'll say it anyway. There's this hilarious Vitalik tweet that he's very bearish on plasma, and I thought I'd bring it up just for funsies in the call. And here are y'all's takes. Have you seen this tweet first? Yes. Okay, so Eureka, you want to say?
Oh, you replied to me?
Yeah.
Shuhei, what's your reply?
We all should check it out. I haven't seen it yet.
I even retweeted. It's about new approved EAP, right? This one or another one?
So this tweet is basically Vitalik saying that he's very bearish on plasma and off-chain layer 2s. So he's bearish. That I guess would include state channels and plasma. And I think that basically what we need to do is we need Vitalik to hop on this call, and we need to chat with Vitalik about all of the cool stuff that we're doing with the OVM and state channels and optimistic rollup, because I think that there is a kind of unifying like theory that means that state, you know, for instance, the difference between off-chain. Okay, so his critique, by the way, is that he wants everything on-chain, like all data on-chain. Which kind of makes sense, you know, because, you know, ETH2 is all about creating more data so you can put more data on chain. And, you know, and I'm actually a huge fan of that. However, at the same time, I think that it's a very interesting kind of, you can, Plasma and Rollup use kind of very similar mechanisms, just on-chain data and off-chain data. And I think that like what we'll actually find is we'll be able to like figure out, you know, on-chain data scales, you know, pretty well. off-chain data scales absolutely obscenely high transactions per second. And we will actually have tooling which helps us build out all of these at the same time. Like, I don't think that it's a kind of like, oh, Plasma hasn't been created or state channels haven't been adopted yet, and that's, you know, that means that it's bad. It's more like there hasn't been a kind of, you know, approach that goes, you know, incrementally towards each one of them. And so that's, you know, OVM. So maybe I just wanted to shill some OVM, but I also wanted to hear y'all's hot takes. That's my hot take.
Shuhei always says there's going to be a less clear distinction between layer 1 and layer 2 for application developers, especially after an advent of OVM, right?
Yes, yeah, I have a question about optimistic rollup.
But you can ask, yeah.
Sorry.
No, I mean, honestly, y'all can ask about optimistic rollup anytime.
He's so obsessed with the idea of rollup.
Yeah. General question. So in optimistic rollup, can we realize the general state?
That is correct.
Okay.
We can. So okay. Here's the kind of differentiation, I think. Plasma and optimistic rollup, kind of very similar architectures, except you know, on-chain data. So what does on-chain data give you? On-chain data, I believe, at this moment, gives you autonomous smart contracts. That is what it does. So it basically takes away the kind of, you know, so you can think of an atomic swap as a smart contract that is autonomous, but can only make one state transition. And that is, I'm going to open my swap and I will allow anyone to match with me. Not the online atomic swap, but the offline atomic swap, right? So that is a kind of like a smart contract that has one state transition. However, we technically, if you're talking about Uniswap, if you're talking about, you know, other smart contracts that are like very autonomous, they're all about this, you know, they're persistent and they make decisions all the time. That gets a little bit more tricky when you have the data withholding problem, right? So I actually, and so if you just put all that information on chain, then you can kind of play the same, you know, interactive validation game that you would play in Plasma, but you don't have the data withholding attack, which means you do have, you know, the ability to write something like Uniswap, for instance, in optimistic rollup. And by the way, I did start writing and post a little bit of a. I haven't finished this. It started out, I was like, oh, I'm going to do this really quickly. And then it became more of like a blog post. But I posted like the kind of beginnings of it with this, you know, optimistic rollup work in progress overview. And so this kind of has some more updated information about optimistic rollup, right? Like you can have you have a developer write a smart contract and then send a transaction to an aggregator. They, you know, include it in a block that they compute locally, right? After applying the transaction, they compute the state root. And then the aggregator will submit the entire block, paying the Ethereum gas, you know, to the main chain through call data, as we all know. And then if anyone downloads the block and finds that anything is invalid, they use verify state transition and they slash the malicious aggregator. They reward the prover with the aggregator's bond, and, you know, everyone's happy. I named the smart contract Sam. This is a draft version. So I'm coming up with a better name. No, I'm just kidding. That's a strange thing to do, to name a smart contract, in case anyone was wondering. Anyway, yeah, so this has like, this kind of post goes over stuff. I maybe don't need to go through the whole post here, but I have there's these three things that I think we need to provide if we want like a kind of public state machine. And that is, we have an available head state, right? So anyone can download the current tip of the state, right? we have a valid head state. So we know that the head state is valid, and we have a live head state. And that means that we can send transactions and mutate that head state. And head state being like the canonical state, the main state, the last state. And so what I'm going to do in this post is just like talk about like how optimistic rollup gives us all three of these things, notably at less scale. Like there's no question. And we need Plasma without a doubt, because we need to get to a point where like we're really scaling up layer 2 transactions. And that also goes for state channels. But this is just a kind of a little scale, but a nice construction. So that's my shill. Sorry.
Yeah, I like it. I guess one comment, and maybe even to loop this back to the juicy Vitalik tweet that you got us started with your call. I think one of the things that we have very quickly seen in like realizing how to do optimistic rollup is that contracts are way easier to reason about because of these fraud proofs, right? I mean, that's effectively what it is. I think if you think about like what is the OVM in the context of optimistic rollup, the OVM is like the language for describing these fraud proof schemes, right? Where you submit some substate, hopefully, of something that was rolled up by an operator, and you proved malfeasance through that subset. And so just like we can do language games, just like the OVM provides sort of like a way to express different exit games in Plasma, we can express different fraud proofs in rollup. And the good thing about rollup is that most of those fraud proofs are distinct from the state transition function, right? Like the contract sort of progression, which makes it very nice for contracts. Like I think generally what we see very quickly is that the design space for those is like somewhat easier than the design space of contracts on Plasma. And so probably what my take on what's going to happen is that we're probably going to see Plasma as like pretty application specific, like high need, like very specific things, right? Like if we want to run an exchange, right, that is like running a huge number of transactions, you probably need Plasma, right? And there's like evidence, for instance, with Uniswap that's not necessarily true, and there are like other interesting exchange mechanisms. But if we want to do a bunch of order book matching, we'll probably need Plasma. But because those exit games are so hard, we got to build them in a more application-specific manner.
I do think that the exit games will be easier and will get easier as we learn more. And I don't think that like our exit game, like I think that Vitalik's kind of thought about reasoning about different people's incentives. I think that we will find a class of exit games where we don't have to like reason so much about like these bespoke, incentive games. And that seems like something that the OVM has really like taught us that we can do, because now we can like think about these things better. We're like better equipped to think about what we're actually building. And so like, I think that kind of education was really necessary for layer 2 in general. Anyway, any last things? We're coming to a close. Andy?
Yeah, I think I mentioned about bonds. So
oh, yes. Oh my God, I forgot about that. I'm so sorry. I was like looking for things to talk about. Do you want to talk about it?
Yeah. So the general idea is basically like we know it's about like exit games, interactive games, and especially we want whenever we challenge, we want whoever started exit to pay off the challenge if the challenge is correct. So we're thinking like we know how much the gas cost of challenge would be. What we don't know is the price of the gas. So we're thinking what we're thinking is we're taking average of like you can get TX that price in Solidity. So we just leverage that and try to compute a bound. But the thing is, it's not perfect because it's impossible for you to predict the future. So whenever you try to do this, your price is still it's gonna always be out of date. So I just want to discuss with like does it make sense to even have this kind of heuristic bound, or like a constant value is always better? Yeah.
It's a good question. I think it's a hard one. My immediate reaction is that this is why we need gas futures. If there were futures markets for gas, then you could denominate the price of bonds in gas, with this collateralized future, and that would be really cool. However, gas price oracle is very hard, like you said.
Isn't how do you use gas token? Isn't gas token kind of a gas price future?
Gas token is sorry.
Yeah, I think even gas token you can at most reward back half of the price because it's rely on deleting the storage, right?
Yeah.
So you could not possibly pay out everything.
Yeah, that makes sense.
Cap that's like 50% or something.
Yeah. I think using the current price of gas as like a heuristic and then like multiplying it by some kind of constant, some kind of factor, I think is somewhat reasonable, and maybe a lower bound as well. That sounds pretty good to me.
You can also attempt to do some sort of like price averaging, some sort of like rolling average of gas. So every time that you do this calculation, that's factored into like a new average price of gas over the last, however many exits. That might be interesting.
Yeah, actually, like that's what we're thinking as well. Like our first invention, we're trying to use the weighted average of the TX price. Yeah, so I just want to know, is this a like reasonable direction, or is it just a bullshit direction to move on?
I am one of the more radical people about my bonding prices and my like economic views. I think that generally speaking, like we want to avoid things like that at all costs. But when we do get to the point where we have to make a choice about like what is the bond price, I'm kind of into the like set a number that is like has a pretty strong, serious security margin and that you can still tolerate, and like not make it very complicated, because it just is like, it's a lot of work to think about like how do you do these gas pricing things. I don't know.
Yeah, I thought we were price. So how are they usually weighed? So we set out a high, like a pretty much higher, generally higher price, so it could almost make sure it covers the challenge, or
I mean, yeah, that's kind of what I would do. I mean, or come up with some rationale for why that doesn't, why a lower, a lower amount can make sense. I don't know. I would have like maybe a minimum gas price, and then do some kind of multiplier on top of that, and then then increase the minimum based on the current gas price. That's intuitively, but I think they're all reasonable.
Cool. Thanks. Yeah, that's probably all for bonds.
Yeah. Cool. Well, that leaves us basically at 11 a.m. So, okay. One last time, I'll give 5 seconds. Looks like we're good. That wasn't probably 5 seconds, but nonetheless, it was lovely seeing everybody. Thank you all for joining, and let's talk soon. Bye.
Everyone.